Thanks for coming in. Really appreciate y'all coming to the first Policy Simulation Library meetup. So we're going to have a couple of cool demos today, and the projects, I guess the first people I want to thank are all the open source contributors to those projects who aren't presenting today, and the users of the projects who depend on these models for making policy decisions. Without the community that's developed around some of the open source projects we're doing, we wouldn't have the models to show you. And then I'd also like to thank the American Enterprise Institute for hosting our meetup and providing coffee, and then we'll have some wine and cheese afterwards, so stick around if you have a time to chat. And just the last thing is we've got the presenters, Weifeng and Cody. Cody's coming in from out of town, braving the cold. Weifeng is in town, but I just want to thank them both for being here to present. And Anderson, who I'm going to turn over to MC in just a minute, is probably still jet lagged from a trip to India where he was helping the Indian government get some tax modeling off the ground using some open source tools. So with that, Anderson, why don't you come up? Anderson will MC for the rest of the evening, and I'll be around afterwards. If you have any feedback on the event, if you want to talk to us about how we can make the meetup better in the future, please do so. This is hopefully a nice community event that we can continue for many months in the future. Thanks, everyone.
Hi, everyone. So like I said, I'll be emceeing this event for the rest of the night. So we got a couple presentations for tonight, and the way that it'll be formatted is each presenter will go on for about 25 minutes presenting their model and the presentation, and then we will have 5 minutes for questioning. So without further ado, first up we have Cody Callan. So Cody is a contributor to the open source tax calculator model and a maintainer of the paid family leave cost model. He's currently a PhD student at the University of Wisconsin-Madison and will be presenting on that paid family leave cost model. So Cody.
As Anderson said, I'm talking about the paid family leave cost model. So we'll just go over a bit of background on paid leave policies in general, the overview of the model, where it comes from and its structure, the different policy parameters we can play with, the different assumptions that underlie the actual model, and then we'll do a demonstration of it. So the motivation for this is the idea that Americans widely support paid family and medical leave, but differ over specific policies, the title of a major Pew report from 2017. Prior to 2017, we only had unpaid leave through the Family and Medical Leave Act at the federal level. There were a few state-level paid leave programs. In 2017, the Tax Cuts and Jobs Act incorporated a modified version of the tax credit proposed in the Strong Families Act, which provides partial support to firms that provide paid leave, but it is temporary. Another prominent proposal is the Family Act, and a few proposals have been made by the administration. So the idea is that this is an area where there's potential for policy in the future, but there isn't much agreement on how to actually go about this. So there are a few different types of paid leave that we talk about for paid family and medical leave policies. The first is parental. This includes paternal and maternal leave. There's also own medical, which is leave for a serious illness. This does not include sick leave, which is administered by your traditional employer. There's also family care leave, time off to care for a seriously ill relative, such as a child, spouse, or parent. And there are a few other categories that are covered by the Family and Medical Leave Act. Now, there are also a few different structures that have been proposed. The one that we focus on tonight is the social insurance approach, or something similar to it. Essentially, a government program that provides benefits with certain duration rules, eligibility rules, etc. There are also a few others that have been proposed as well, such as an employer mandate. Although this doesn't really show up on the budget, it does have economic costs as well. However, since we're focused on modeling the budgetary costs here, we're going to ignore that. There are also the tax credit approaches, such as that used in the Tax Cuts and Jobs Act and the Strong Families Act. Now, as I mentioned, we're going to focus on the social insurance approach, which relies on the duration, waiting periods, and all these specific rules that would go with it. The original version of the model came from Ben Gittes at the American Action Forum, and then as part of the AEI Brookings Working Group on Paid Family and Medical Leave, Ben Gittes, Jeff Hayes, and Sarah Jane Glynn worked together to combine their own modeling approaches to paid leave to better understand why their results differ and, importantly, how the assumptions that underlie them affect the results. Ben and I then prepared an online cost modeling tool. It's very simple, just a couple of bars or toggle bars with some pre-generated output, but the underlying code for this became the PFL-CM model. As for the actual way that this works, we start with the 2012 FMLA public use file. This has lots of useful information on leave taking. So we break this down by types of leave, we look at durations, we look at who receives pay and who doesn't, and we interact all of these together. Using these, we can come up with a picture of essentially all sorts of useful information on who takes leave, how long, and so forth. And then we can combine these with the actual policy parameters of the program to produce an estimate of the expected amount of time, ex ante, that a person will spend on the program or on a public program. And then we pull in the current population survey microdata for March 2017, which is somewhat larger and has lots of information on income and work hours, which we can combine with eligibility rules and the actual structure of the benefit payment. And from that, we can come up with an estimate of the expected benefit for each person, and as well as the total cost estimates for the program. Now, unfortunately, there are some serious limitations in what we do here. So one of the biggest problems is that we are essentially operating blind. There is no large paid family and medical leave program at the federal level that we can use to model take-up estimates. So there are generally two approaches to this. One is to use FMLA take-up. That's the general approach we use in the PFL-CM model. So in other words, we can use the FMLA data to estimate who takes leave, and then assume that if you take leave and you can go on the program, you might go on it. Alternatively, you could look at state program take-up. Unfortunately, this is relatively low. Part of this is due to simple lack of knowledge. For example, in California, a few years ago, they found that half of new low-income mothers eligible to take paid maternity leave didn't know the state program existed. So this is likely one of the biggest contributing factors, but we're not entirely sure what holds back take-up at the state level. There are also, unfortunately, some limitations in the FMLA public use file. The biggest one being it's not very big. It's only 2,800 observations. So as much as we would like to splice and dice the data set to get as granular a picture as possible, the limited size just imposes some limitations on what we can do. Then, of course, it also has somewhat limited information on income and payment. In particular, it does it by groups, but we would like more precise information. And, of course, it's out of date. It's from 2012. Fortunately, there is a solution for that last problem. Abbott Associates is currently working on the next stage of the FMLA survey, and hopefully they'll have a bigger, richer data set out for us sometime in the next couple of years. And then there's also a limitation with the actual income data, the CPS. We're using the March 2017 data, so this only produces a total cost estimate in 2017. One of the potential expansions, hopefully in the near future, will be to add growth factors so that we can calculate these total costs, not just in 2017, but all throughout the budget window. As for the actual policy parameters that we can include here, we have a few duration parameters. So the maximum duration, the amount of time that a person can be on the program in a given year. Then we have a waiting period as well. These are both denominated in weekdays, 5 days per week. This is consistent with legislation and with the data in the FMLA public use file. Then we have a few different benefit structure parameters. The most basic one that we think of is the replacement rate. This effectively acts like a phase-in rate. So if you're in the phase-in region, an additional $100 of weekly wages with a 70% replacement rate corresponds to an additional $70 benefit. We also have a maximum weekly benefit, and we allow a minimum weekly benefit. And we also have recently added in some parameters to allow a phase-out of the benefit for higher income levels. This would be consistent with the approach recommended by Ben Giddis and Angela Rashidi in their Earned Income Leave benefit, which would provide a paid leave program structured similarly to the EITC. And finally, there's the question of who can actually take paid leave. So there are, of course, the work requirements. There are some complex rules that have been proposed. Right now, we only have them in work hours. One change I'd like to make in the future is to add in SSDI eligibility rules. And then, of course, there are the types of leave that are actually included in the program. For example, a paid leave program might just include parental leave. It might include parental and own medical leave, but not family care leave or other types eligible for that are covered under the FMLA. Then we have a few different take-up assumptions. So the basic ones are the overall take-up rates. Unfortunately, one of the limitations of the FMLA public use file, it doesn't replicate the headline take-up rate in the actual report of 15.9%. So we have to put that in directly. There's also the question of incomplete program take-up. In other words, some people take leave but don't actually go on the program. This allows us to start with the FMLA data and approximate the state-level take-up rate, or the take-up rates for state programs that we observe. And then there are the questions of how will employers respond to the creation of a federal paid family and medical leave program. So these generally break into three approaches. So the full push, in other words, employers who would have provided paid leave in the absence of the program instead have their employees immediately go on to the federal program. If the employer benefit would have been more generous, they of course can still top that up. There's also the idea of a partial push, in which perhaps there are some fixed costs to pushing employees onto the program, so they only push them on after some duration of leave. In this case, we picked 4 weeks. It's a little bit arbitrary, but there's no evidence to go on for that. But that is one of the assumptions that you can change. And then there's the question of no push. In other words, employers who would have provided paid leave in the absence of a federal program continue to do so even though they could potentially reduce some of their costs by pushing employees onto the program. And now let's move on to our actual demonstration. So this is the GitHub page for the model. You can check it out yourselves. Now the way that this works this file, centralcommand.do, is on the GitHub page. It's essentially the easiest way to run this yourself. So you have to specify the parameters, you have to specify the assumptions, and then you just can run the model. And this will take a few seconds. All right. So the model itself spits out 3 numbers. The first is the expected benefit, in other words, that ex-ante expected benefit that a person will receive in the given year. And this is potentially useful for distributional analysis, but it's not really useful for the headline cost estimates. The ones I'm more interested in are the total cost and the payroll cost. The total cost here is in dollars. Alternatively, you could put in billions. So the program I ran here is just about $50 billion. There's also the payroll cost. In other words, the total cost divided by the wage base. If you wanted to create such a program and finance it through a payroll tax, this is the payroll tax that would be required to make it budget neutral. Now let's go through a couple of actual examples here. So let's start with a modified version of the AEI Brookings Working Group proposal. So 8 weeks of leave, 70% replacement rate, maximum weekly benefit of $600. And let's say that it will not include leave for military purposes, leave for any other reason. And in this case, I'm having it spit out the results in a more palatable format. So this gives a total annual cost of $49.01 billion in 2017 and a required payroll tax of 0.567%. Alternatively, we could consider a larger program. So let's try 12 weeks of leave. Let's say, stick with the 70% replacement rate. Let's try a maximum benefit of $1,000 a week. And let's add on a minimum benefit of $150 a week, which corresponds to a 100% replacement rate for someone working 20 hours a week on minimum wage. And let's include all types of FMLA eligible leave. And this comes out to a cost of $77.3 billion a year, required payroll tax of just under 0.9%. Now let's suppose we look at a smaller program. So instead of 12 weeks of leave, let's say it's just 6 weeks, so it's 30 days. And let's go with a high initial replacement rate with a low cap. So 90% replacement rate up to a maximum weekly benefit of $500. And let's say that it phases out at a 10% rate. And let's say that it phases out on usual weekly wages in excess of, say, $1,500 a week, roughly $75,000 a year. And let's have it only include medical leave. Let's have it not include family care leave. And let's have it include parental leave. And you'll notice this comes out to a much smaller cost, only $32 billion a year. Now, one of the big value adds of the collaboration between Gittes, Glynn, and Hayes was discovering just how important the underlying assumptions are in determining the actual cost. As I mentioned earlier, we're largely operating blind, so there is going to be an enormous confidence interval on any estimates. So let's go back to a modified version of the AEI Brookings proposal, 8 weeks, 70% replacement rate, $600 maximum weekly benefit, no phase out, and let's include all types of leave. And let's go with the FMLA take-up. Here we see the reduce underscore variables. These are setting these as 1 says that we're just sticking with if you take FMLA leave, then you would also go on this program if you're not paid by your employer. And let's go with a 70% full push. So 70% of employers who would have paid their employees immediately push them onto the program. And let's say there's a 30% partial push. So the remaining employers continue to pay for the first 4 weeks and then push employees onto the program. So this comes out to a cost of $44.7 billion a year, a required payroll tax to finance it of just over 0.5%. But now let's consider a really low-end estimate. So let's look at state-level take-up. So instead of 100% of those taking leave going on the program, we're going to say 50%. And for of those caring for an ill child or spouse, we're going to go with 20%. Those caring for an ill parent, or other relative, let's go with 10%. Let's go with those for military leave, 90%. Those going with parental leave, 90%. And let's just set this remaining category to 0. Now, these numbers didn't come out of nowhere. They were one of the findings from that collaboration between Gittes, Glynn, and Hayes on how important, or essentially what take-up rates do we need to adjust in order to get these estimates to reconcile. And of course, let's go with very low employer push assumptions as well. So employers who would have provided paid leave either half of them push them onto the program after 4 weeks, half of them just continue to provide paid leave. No employers push their employees onto the program immediately. And now, of course, instead of running with $44.7 billion a year, it's all the way down to 12. So this is a substantially cheaper program if you end up with very low take-up, and employers just don't use this benefit for the most part. And then, of course, what if we have something on the other side, so very high take-up? So let's reset all of these take-up adjustments to FMLA leave, and let's say we have a 100% employer push. In other words, those who would have been paid all are immediately pushed onto the program. And let's suppose that because the government or the federal government is suddenly providing paid leave, that more people take leave. So instead of a 15.9% leave taking rate, let's bump it up to 20%. And now we're all the way up to $62 billion a year. So, in other words, although my preferred estimates are around $40 billion or so, there's pretty clearly an enormous range. And in the absence of such a program that we can use to generate better estimates of take-up and how employers will respond to the program, there's just not that much we can do about that. And finally, there's the question of doing this yourselves. So the code is all up on GitHub. You can download it freely. You can use it freely. We'd appreciate it if you cite us, but now, as I mentioned, there's the central command.do file. It lists all of the policy parameters, all of the take-up assumptions, and you can easily run it from here. Alternatively, once you've actually specified the policy parameters and the assumptions, you can run it from the underlying file, runanyassumptions.do. This is the workhorse file. This does all the computations. So if you run it from here, you can get the actual expected benefits per person, and you could potentially do a distributional analysis that way. All right. So, all right. Now, if you have any requests for policy parameters, questions about different assumptions you'd like to use, I recommend going to the GitHub page for this. You can open an issue. You could make these changes yourself and open a pull request. We're certainly open to your contributions and to any questions you may have. All right, and I'll take questions now.
So the assumption about the take up, the proportion that take up, are you assuming that there's no a relationship between that and the income, individual income, that there's not, it doesn't differ across income?
It should. Unfortunately, as I mentioned, the FMLA data file doesn't actually replicate what we would see in the full report, or if we had access to all of the data. So we have to essentially approximate it. And as I mentioned, one of the limitations, we have a pretty small data set that we can use here. I would love to use different income groups, but there's limited ability for me to do that without making groups too small to get reliable estimates.
Why is the data set so small?
I think they had some issues with the actual data production, but I'm afraid I don't know why they made it that small.
You have assumptions regarding employers who offer family paid leave. I'm not sure I understand how employers are supposed to react to this when they do not have such a program of their own.
So, as in, for those who don't provide paid leave prior to it, we assume that if the employer was not providing paid leave, then the employee would automatically take the public program.
And what happens to that employment position?
It remains. So this is job-protected leave. So if they took leave under this program, it would continue to be protected leave under the FMLA.
So this is also a tax on the employers that otherwise would not offer such leave in any case, because now they have to fill a position, at least in the interim.
Not exactly. So they would, if the person is taking leave and the employer is not paying them, this isn't a tax on the employer. It's not.
No, but they have to have that. They are missing the services of that employee.
That's correct. They would be missing them anyway if the program does not affect leave take-up, but there's the potential for some distortion. That's one reason that the employer mandate has potentially serious economic costs that wouldn't show up in the budget.
And none of that is in the model.
None of it. We can't do that. Any other questions? All right, then.
I got another one if I can have.
Go ahead.
This is actually my third one, actually, so I feel like I'm cheating, eating all the cookies on the plate. You're making the assumption that there's no fraud, though?
I am not necessarily making that assumption. So one of the things that I have in the actual documentation on the GitHub page is the reduce child health, those variables. If you were to set those to be greater than 1, that would be consistent with an approach of people taking leave who shouldn't be. All right, and then I will turn it over to Weifeng, or to you.
All right, thank you, Cody. So like you said, next up we have Weifeng Zhang. Weifeng is a research fellow in economic policy studies here at AEI. His research focuses on Chinese economic issues and the political economy, and he'll be presenting the Policy Change Index for China to us. It's a machine learning model that can predict future changes in policy by detecting relative changes in propaganda. So, Weifeng. And like with Cody, we'll have a 25-minute presentation, 5 minutes of questions afterward.
Okay, thank you. Thank you for coming to this event. Such a joy to be in the launch event of the Policy Simulation Library, and also to talk about the launch of our machine learning project that predicts policy changes in China. Also, my co-author Julian Chen, who's an economist with Batesy, also in DC, is here today. And before I start, let me say first that I'm going to express a lot of views and opinions in the presentation. So I want to make sure to say that they are only those of our own, and they do not represent the views of AEI, Batesy, or their other employees. Okay. And also, my understanding is that the presentation is, the format is a little like a workshop kind of talk. So if you have any clarifying questions, feel free to raise your hand or shout it out. Now, the reason we are doing this, let me give a little motivation. So as we all know that the industrialization process of China has long been a product of government direction, right? So we have the central planning, of course. But even these days, we see a lot of constantly seeing aggressive industrial policies, right? But in the literature, there have been no quantitative indicators that could tell us what the Chinese government are up to or what they are going to do next, right? And so the reason we are all we do all this is to come up with the first ever leading indicator in the literature that can predict what the Chinese government's next moves are. The product, the Policy Change Index of China, it's a leading indicator that runs from 1951 all the way to the most recent quarter. It also can be updated in the future, so that what that means is that in the future, we have an index we can look at, and if when you see the numbers, you'll be able to say, aha, President Xi Jinping may be up for something. Now, how do we do that? It would be great to have an indicator like that. So the way we're going to do this is to read the People's Daily. As some of you may know, is the official newspaper of the Chinese Communist Party. It was started in 1946, and we have just about every single word ever published by this newspaper to the present day. Now, the scale we are talking about here is about 2 million articles, right? So we are not really going to read it ourselves. We won't be able to finish before we retire anyway. So what we are going to do in this project is to build a machine learning algorithm to process these words, and we are going to use something in machine learning that's called artificial neural networks. So it basically mimics how our human brain or biological neural networks work in processing images and text. Now, the ultimate task of doing this for the machine is to pick up whether there's change in the way the newspaper covers or prioritizes policy issues in the publication. Okay? Now, you may think that, what does it have to do with predicting policies, because nothing really on this slide is about predicting policies. But actually, if you do this, it turns out that it has predictive power, because as we all know, the People's Daily is at the center of China's propaganda system. It's organizationally speaking, it's actually under the Central Committee of the Communist Party. Now, we also know that propaganda often precedes policies. Right? The good example to think about is, say, the beginning of the economic reforms in China in the late 70s. Now, at that time, at the dawn of the economic reform, China had basically gone through decades of planned economy, right? You have central planning, communism, and everything. Now, if you were the leader of the Chinese government at the time and you wanted to pursue pro-market reforms, right? What you have to do is you've got to explain to your people, what's going on, right? Otherwise, they will be wondering, what are we doing with communism? Are we, why are we changing? And so that's why if you put these two together, although at the technical level, what we are doing in the paper is to detect changes in propaganda in real time, we are really predicting policies that may change in the future. Now, the question is, though, that, the key here is whether we can detect with the machine changes in how the newspaper prioritizes content. But priorities is such a vague concept, right? So how do we even define what's the priorities of the newspaper? But luckily for us, in the data set, there's the page number for each article, right? So front page is something, such a great proxy for something that's so important enough, you have to put it in the front without people flipping the newspaper. So we are going to exploit this fact in the construction of the index. Now, let me explain a little bit how we actually do this in detecting changes in propaganda. Now, I have two versions of that, by the way. One is a human version, and then we have a machine version. So the human version basically goes like this. So imagine that you are an avid reader of the People's Daily. Okay, I understand it's not your favorite tabloid, but just work with me and imagine that you read that every morning, right? And by the way, this is actually China watchers, they have to do this all the time. And you pick up the official newspaper, read it, and see whether there's something strange going on. Now, what would happen after reading this publication for a while is that you would be able to form a paradigm about how propaganda works in this newspaper. What goes on the front page, what does not. Okay? Now, after you have acquired that state of mind, what if you read some new articles and apply your knowledge or your understanding of the newspaper? It's basically a reverse engineering of the People's Daily editor's brain, the mind, right? So now you apply this knowledge to new articles, but then it may or may not work. right? So it could be that you pretty much guess it right, but it could be that you are way off. And when you're way off, it means that something must be fundamentally different in those articles compared to what you have learned before. And what that would mean is that it would indicate something is fundamentally different in the government's priorities than what it used to be, right? So this is basically how the machine learning algorithm is going to work on a conceptual level. So this is the human version. But when we put to the machine version, what we are going to do is to say that let's take 5 years worth of articles. So we are talking about tens of thousands of articles because it's a daily newspaper. We are going to divide the sample so the articles within these 5 years into 2 sets. One is called modeling, and the rest will be testing data. And so what the machine is going to do is that we are going to feed the machine with all these examples of articles and whether or not they're on the front page, and ask the machine to figure out the function behind the editor's mind when or whether each article goes on the front page. Now, after you've done that, it's basically like a student studying for exams, right? You start your homework first. Now you're going to take 2 exams. One is to apply your knowledge to the testing data, which are coming from the same time period of the 5 years, right? So in principle, they should be similar because they are random sample. But the other exam you're going to take is what we call the forecasting data. It's quote unquote because we are not really forecasting. Everything is in the data set anyway. But if you apply your knowledge to the newspapers published in a quarter immediately following the 5 years, things might be different, right? So now when we calculate the PCI, we are basically taking the difference in performance between what we call the testing data and the forecasting data. Now, what does it mean? Let's think about it. If PCI is close to 0, it means that things are pretty much stable. What you see in the new quarter are pretty much, by your own judgment, similar to what has happened in the past 5 years. But if PCI is significantly larger than 0, what that would mean is that something must be very different in the articles published in that new quarter. Okay, and so this is basically how we calculate the PCI. Now, I hope that you can see there's a feature of this method that's pretty clear now, which is that the method is basically language free. Now, as researchers, me and Julian, we understand the Chinese language, but we didn't apply any of our knowledge in it. We basically feed the algorithm with a lot of articles, and the article reads the machine reads the articles. We didn't read it, and we basically provide the answers to the machine. What page it's on. So we are not in charge of figuring out what goes on the front page or not. And so this feature actually suggests that the same method could potentially be applied to a lot of applications that are structurally similar to the problem we are dealing with here. And I'll go back to these applications closer to the end of the presentation. Now, but for now, let me talk a little bit more about how it works. Right? Everything on this slide is pretty much straightforward except for the modeling part, which is basically how exactly the machine is going to figure out what goes on the front page. So the raw data we have looks like this. So this is a snapshot of the data from October 1st, 2018. It's a national day in China. And as you can see, if you read the language, it's National Day, everybody is celebrating, and President Xi did some stuff. But the point is that you don't need to understand that because we have the page number, and then you just feed it to the machine, right? Now, when we do this, we take each article as a observation. We have the words, the Chinese words. We have a set of metadata variables. We also know the page number, but we are not putting in the input because that's the output. It's what the machine is supposed to find out. Now, what goes on in the middle from the input to output, though, is a very complicated function f. We apply here a set of machine learning techniques. The first step being that since words are very complex unstructured data. So the first step we are going to take is to say we are going to reduce the dimensionality of words into a vector space such that each word is represented by a numeric vector. So a article, which is a long string of words, would be a matrix. And then if 2 points are close to each other in a vector space, it basically means that 2 words or 2 phrases they have similar meanings, right? And so basically what this step does is it reduces the complexity of the data while maintaining largely the linguistic meaning of words that we humans see in the reading. Now, after we have done that, the second step would be something called recurrent neural networks. And it's basically based on the recognition of the fact that texts, they come in sequence. So as human, when we read the words, we read an article from the top to the end, right? And this is how the machine is going to do that in the algorithm too. Now, after that, and simultaneously, we have a track that processes the metadata variables. And then in the end, we are going to combine everything together, put it in another layer of neural networks, and in the end, it gives us the answer of whether it's on the front page or not. Now, the function f could be as simple as possible or as complicated as possible. The ultimate goal is whether we can actually have this function f that works. As long as it works, we can just simply plug that in the formula of PCI, and then we can calculate how the machine is doing in the training period and how it is doing in the new quarter. Now, we have done that for you, so then we have the chart to see the result, right? When we put everything up, it looks something like this. Now, let's stare at it for a second and see, whether it makes sense or not. So there are 2 questions after you look at this picture. One is that since I submitted to you at the very beginning that we are having a predictive algorithm, right? So what's the ultimate test of a predictive algorithm is whether it actually predicts the policy changes that we said we are going to do. So the first step we are taking after getting this picture is we ran a comprehensive survey of the academic literature, and then we put together a list of events that those China watchers who read newspaper articles every day and then watch what the Chinese government is doing. The set of events that they agree are very important for the Chinese economy. And then we throw that up to the picture. What does it mean by a predictive algorithm? It means that the index has to move before an actual policy happens, right? So if you see a spike there, which then is followed by an actual policy change, that means the movement of the index predicts the policy change. And I don't have enough time to go through all this, but let me briefly say that it predicts many of the major policy changes that happened in China in the past 7 decades, including, most importantly, the beginning of the economic reform program in the late 70s. And then we also have a reform speed up in 1993 and a reform slowdown in 2005. So for all these events, you see the movement of the index first, and then you see the actual policy change. Now, let me instead spend the time in talking a little bit more about when it doesn't work, because it gets us to the limitations of the methodology. Now, the most obvious limitation is that this is the government newspaper, right? State-run media, which means that if there's something that the government doesn't want you to know or doesn't want you to talk about it, then we won't have any chance of picking things up. The most obvious example is the 1989 student protest on the Tiananmen Square. So if you look at that gray curve, right? I don't have a laser pointer, but if you look at the year 1989, you'll be able to see that the index was very, very low, all the way down to almost 0, for obvious reasons, because they didn't want you to talk about it. On that day, in the newspaper, there was actually a front-page article about the shooting on the Tiananmen Square, which barely exceeds 100 words. We clear the square, and basically that's it. And so that's why if there's something important, but the government doesn't want it to show up in the newspaper, then we don't have any chance of predicting the changes. But overall, besides exceptions like this, it works pretty well in predicting many of the most important policy changes. The second question, though, looking at this chart, is that, so now we know that the movement of the index predicts policy changes. Now, the second layer of the question is that when you see a movement in the index, but before the actual policy change happens, do you actually know, what the change is going to be about? Because the index is just a number, right? So you know something's going to happen, but do you know what exactly is going to happen? And the answer is that you can actually find out the substance of policy changes, because what we are relying on basically is when exactly the algorithm goes wrong. And every time the index goes wrong, the algorithm goes wrong, two things must have happened. One is that there are some articles that was considered so important by the algorithm that they should be on the front page, but it turns out it's not. Right? So they basically fall off in terms of the priority. But also there are other articles that the algorithm thinks is not that important, shouldn't be on the front page, but they actually come on the front page. So that would be the new, policies of the new agenda, content of the new priorities, right? And so by looking at these type 2 and type 1 errors, you can actually see the substance of the upcoming policies. So that means that with this technology, you would not only know the timing, but also substance of the upcoming policy change. Now, I mentioned, since I mentioned earlier that the method doesn't rely on actually reading the articles until you have to find out the substance of the policies. But to come up with the index, it doesn't rely on human reading of the text. And this is why it suggests a wide range of applications, which I'm going to talk about a little bit more here. The most obvious one is that there are, obviously China is not only a government that has an official newspaper, and there are many other ex-communist regimes or communist regimes, they have official newspapers. Now you might say that, Soviet Union, East Germany, they don't matter anymore because they don't exist. But we have North Korea, Cuba, and Vietnam, and all these newspapers, they are still in print today. So what that means is that if you manage to get the original text and run through the whole program, you could have the policy change index for these countries as well. And I'm very excited to announce here today that we are actually working on PCI Cuba, and there might be a chance that we can get the data and do the PCI North Korea. And of course, if you have other newspaper text, you're also welcome to try it out. Now, these are all ex-communist regimes, right? They're autocracies. But what about democracies? Let's think about the U.S., right? What if we have all these newspapers: Washington Post, New York Times, and Wall Street Journal? What if you run the same program on all these American newspapers? Now, they are not propaganda machines. You may think that, but still, they are not the mouthpieces of the White House. Right? So even though you get the quote-unquote PCI for Washington Post, New York Times, or Wall Street Journal, they are not predicting U.S. policies. What they are really doing is just picking up changes in these newspapers' priorities. Now, suppose you do that. What you will have is 3 curves for all these U.S. newspapers. Now, I ask you, what would it mean if you see these curves drifting apart from each other? What that would mean is that the priorities of these newspapers are much more different from each other than before. That would be an indirect indicator of the polarization of the media outlets. Now, if it's the reverse, meaning that they come together, then that would mean that they are starting to have similar priorities again. So that would be the reduction of the decrease of polarization. And so by studying U.S. newspapers, we are not going to get any predictors of the U.S. policies. But there might be a chance that we can get predictors of policies in another venue, which is the third application that I would like to talk about. Now, in the PCI China project, what we have are newspaper articles and what page they're on. Now, imagine that you have a bunch of statements made by politicians who, in the U.S., would be those who are making policies. Now, you have the words, what they said what they say publicly on TV or on the congressional floor, and you have the names. Now, you could potentially develop an algorithm that predicts the names of the legislators by looking at what they say. Now, the question I ask you at this stage is that what if you have a machine that works in predicting names? What if a statement made by Senator Bernie Sanders is mistaken by the algorithm as coming from Senator Ted Cruz? Well, it's a fantasy, I know, but let's imagine that that's the case. What that would mean is that what Bernie Sanders is saying right now resembles what Ted Cruz has been saying in the past period of time. Now, what this would mean is that the positions that the statement represents for Bernie Sanders is now closer to the previous positions represented by Bernie Sanders. Sorry, Ted Cruz. Okay? Now, this thing might even have predictive power because just like why the Chinese government wanted to change their words before they change their actions, politicians may want to change their words before they change their votes too. Right? Especially if you want to, as a senator like Bernie Sanders, if you wanted to vote in the manner of Senator Ted Cruz, you might as well say something on TV and so that your voters are not too surprised by what you're trying to do. And so this potentially would tell us the vote predict would have the potential ability to predict vote changings by legislators. And because of the limit in time, I would like to mention that we have other potential applications that we mentioned in the research paper, and you're welcome to check it out and see, and also whether you would like to come up with something new that also uses this method. And I would like to spend the last minute also to do a salesmanship. If you are interested in DIY, I want to say that everything is online on GitHub, and you can download our code and modify it and use it in other occasions. And I'm going to use this time to show you the website. The easiest way to find out everything that I mentioned today is to go on the policychangeindex.com. It should show up in the screen momentarily. And that's a one-stop website that we designed so that you can find out, including not only the research paper, but also what's going on in the later developments in our project. So you see this chart is basically the same as what you saw in the presentation slides. And if you move your cursor around a little bit, you can see, let me see. Okay, for example, here you can see that we picked up some movements in 2004, which predicts the policy change in 2005. And then you can move your cursor around and see all the other policy changes that we can predict. And also, if you go to GitHub, you can see all the codes we have there in the repository. Let's see. Can we have the GitHub? Okay. So you can fork us and then come up with new projects. And we, of course, welcome any comments or questions or suggestions you might have. And another thing I would like to mention, if we could go back to the slides again with the hyperlinks, is that many of you might find it difficult to directly apply our method because you may not have the newspaper text for China or maybe for North Korea or for Cuba. So about next week, we will roll out a new piece in which we provide a simulated example in which we'll fix some news for you and then we fix some policy changes. And we are going to show that the same method can recover whatever policy changes we manufacture. So it's meant to show, it's not real news, but it's meant to show you that the method actually works and then you can use it for other purposes. I guess that's about it. And then the next one would be, I'll open up for questions if you have any. Yes, please.
So when you looked at the false positives and the false negatives associated with some of the specific increases in PCIs, like the late 70s, was it what you expected, that there were false negatives around economic liberalization?
Yes, exactly. And so what goes, quote unquote, goes out of the priorities so that would be false positives, would be those about class struggle, putting people in jail, all you have in the 70s. And then the false negatives would be those that says how important education is, how important opening up, focusing on the economy is, and how we should stop putting people in jail, basically. So it's the answer is yes.
Were you able to open up the black box and find any patterns or heuristics from how the predictions are made? Especially given that some of your applications have much smaller data sets. Bernie Sanders may have been around and stated millions of things since the 50s, but if I want to know what Senator Ocasio-Cortez is thinking, like how would I use this model to learn?
So far, we are basically relying on the consistency of the behavior of the Chinese government, meaning that before they do something differently, they say something differently. And so that consistency has helped a lot in coming up with the index. Now, for senators, for example, who are or Congress people who are newer, then you may not have enough data for the algorithm to learn. But that would be the limitation of the methodology already.
Sure, sorry. Yeah. I always have trouble reading the People's Daily. Every article seems the same to me. Everything is great. The party's doing great. So do you have any advice does the model have any advice for me as a reader about how to make these predictions? Oh,
I see. So yeah, the point is that you don't, so with this machine that you don't need to read it anymore to know the timing of changes. And so you can just look at the index, and you only need to pick up the newspaper when you see a jump in the index, the value. Now, so there are two layers of the question. So one is that we at this stage, we have the ability to understand the substance by reading misclassified articles. And the other is that can it be even easier than that, which is something we are still working on. And hopefully in the future, we will have an easier way to say what exactly inside the black box of the machine learning algorithm, what exactly is causing the algorithm to recognize certain words, perhaps, or certain phrases to be important enough to be on the front page. We are not there yet, but we are in the development stage of that second layer of the answer.
Thanks. And Weifeng, this is really fascinating, actually. I've got about a million questions, but I'm going to stick with two for the moment. One, in thinking about policy development, policy implementation in China, obviously a lot of this does take place in terms of top-down direction that then works its way through specific policy drivers. But what are you thinking in terms of some of the specific policy details or specific policy pieces that also move from the bottom up? I mean, if you think about China and sort of using implementation at the local level that then builds up to the specifics, are you thinking about developing the model or developing the implementation to take this into account, or how should we think about that issue? And the second question is, thinking about, People's Daily as propaganda to policy, you also see instances in which the language or the propaganda around specific terms changes without necessarily signaling a real detailed change to policy. So you think about use of the term scientific development or things that were catchphrases under Hu Jintao that are not necessarily in vogue now, but it doesn't necessarily signal as much of the policy change. So how do you separate out or think through areas in which you may have changes in the propaganda that don't necessarily signal changes to the policy?
Thank you. So to answer your first question, we actually have a paragraph in the paper that talks about that. So in China, not only we have a national official newspaper, but every province and every city, they have their own official newspapers too. And so what you could do, we haven't gotten all the data yet, but potentially if we have, say we have the universe of all the Chinese newspapers, every single one of them is official. But if you run the same algorithm, you have a PCI for the central government of China, not only that, but provincial governments of China. And you would see that for provinces that are typically farther away from Beijing, they are freer, and then they may be coming up with some policy experimentations, and they might be saying things that are slightly or more or less different from what the central government is saying. So One idea for potential application is to do all the provincial newspapers, coming up with all the provincial PCIs, and then you can see which province is moving faster compared to the rest of the country in terms of reforms. So that's an excellent question, and we are actually thinking along that line. But due to obviously data availability restrictions, we are still not there yet. Now the second question is that, so when we build these algorithms, we are trying to detect changes that are sudden, right? So obviously, from a linguistic point of view, terminologies have changed in China. We even talk about the same subject in very different ways compared to what we used to do, say, in the 50s or 70s. Now, there are two kinds of changes that could happen in the newspaper over time. One is more gradual, due to changing culture, changing basically the real world. But if the movements are not sudden, then because of the research design, we have a moving window, right? So if you pick up something slightly different, then the index will be staying pretty close to zero still. So what we would really pick up is movements that are really sudden. For example, when the president rolls out new policy agendas, it often comes with new slogans, harmonious society. Then what would happen is that what comes with these slogans are a set of social policies that are very different from what they used to do. So for occasions like that, you would be able to detect real policy changes. Any other questions? Yes, please.
Thank you. This was very, very interesting. Since you mentioned that it was sort of language neutral, right? Could you see a use case where you would be looking across countries, similar to what you described here in the US? Let's say you looked across newspapers. You looked at the Washington Post, New York Times, Wall Street Journal. I'm wondering if you can detect, if it could be applied across countries, think Eastern Europe, for example, to detect polarization in a direction or another.
I'm not quite sure. So in the sense that the reason we are focusing on within a country, so within the US, then you pick up different newspapers, is because the scope of the content on the newspapers are more or less similar. But if you go to a cross-country basis, then each newspaper by each country is going to talk about their own things. Sometimes they may talk about international relations, but I think ideally you would want publications from all the countries that are mostly on international or regional issues. So then you have a similar scope. That way you could compare. But that may or may not be true, right? So even for China, right, one may ask that, is there any chance we could specify policy changes that are about the foreign policy issues? So then the People's Daily won't do, because the People's Daily is mostly about domestic issues. Then you have to find official newspaper in China that are focusing more on the international news or foreign policy issues. So the scope would matter a lot in these kind of applications. Thank you. Any other questions? If not, then I'll hand it back to Anderson. Thank you very much.
Okay, so those are all of our presentations for the night. I want to thank our presenters, Cody and Weifeng, again for their time and presenting their very interesting work. And thank all of y'all for coming as well. If you would like, there will be wine and cheese out in the hallway if you want to stay and mingle and maybe talk to the presenters a bit more. So thank you again for coming, and we look forward to doing this again soon.